Welcome to Ask and Learn.
Hello students, let's begin with this question. In this question, we have to write down the about the E1 and E2 mechanism for the dehydration of 2-methylhexanol and some other compounds. So firstly, let's write down the reaction here. So this is the structure of the 2-methyl cyclohexanol. So in the presence of acid H positive, here there is a formation of there comes a O positive, H, and here is the CH3. So now here water will leaves out, and here is the positive charge now. Now this is the less stable carbocation. So generally 2 degree and 3 degree carbocations are more stable, and 3 degree is more stable than 2 degree. So here there is a possibility of, so here comes the positive charge, so here is the hydrogen. So here this one is the product formed. So if we this is followed by the E1 mechanism. So now if we talk about the E2 here, so in the case of E2, so the base will abstract the beta hydrogen, and it will the base will abstract the beta hydrogen from the adjacent carbon, and it will result to the formation of the, it will also lead to form this product. So in this case, in both E1 and E2, the here the more substituted alkene is more stable according to the ZF rule. Now E1 and E2 product formed is the 1-methyl cyclohexene as a major product. Now let's see. Next is the dehydration of cis and trans. So if we draw their structure, so this one is the cis one, and in the case of cis, here in the presence of H3PO4 minus water, this will result to form this as a major product. So if we talk about the trans here, so in the case of here is the CH3 group and here is the OH. So here is H3PO4 minus water. So in this case also, there is a possibility of one this product and one this one. So here in this case, in the case of this cis, E2 is not E2 mechanism not occur due to no antiplanarity available, whereas in case of this trans in case of trans, it will follow both E1 and E2 mechanism, and here the major product formed is the 1-methyl cyclohexene. Now the next one is the dehydration of 1-methyl cyclohexanol and the 3-methyl cyclohexanol. So here if we write down the reaction here, firstly the 1-methyl cyclohexanol, so this is the structure of 1-methyl cyclohexanol. So there is a formation of one double bond is having at this position, another one is double bond is having at this position. So this is the major product formed according to the ZF rule. So as this is the more substituted alkene. Now next is the 3-methyl cyclohexanol. So this is the 3-methyl cyclohexanol. So there is a formation of, first one is this one, there is a formation of 3 products, and out of them one is the major product. So in this case, so now if we see in case of the 1-methyl cyclohexanol and the 3-methyl cyclohexanol, so both will occur, so both occur via E1 and E2 mechanism, E1 and E2 mechanism. So in this case, here the major product is the, this is the forming the 2-methyl, here there is a, now the major product formed over here is the, this is the 1-methyl cyclohexene, whereas in case of this, here the major product formed is the, in case of 3-methyl cyclohexene, 3-methyl cyclohexene as the major product. I hope this video is useful for you to understand this problem. Thank you.